Yo, welcome back to part 2 of this AI tutorial. So this time we're going to be converting this AI that we created last time into a class. So instead of having this one script here for every AI, we'll change it to a class. And then we'll also introduce the method of initializing this AI, so creating the AI class for it, to manage the AI for every AI under the game. So what I mean by this is we can have a folder of NPCs, and I can put them under there. This AI script, we're going to move to server storage for the moment. And pretty much every one of these under here, under this one folder, will run the same AI. And obviously we'll include performance improvements like we've done with this move to, where we insert into a table and then that table manages all the AIs at once. And I may introduce pathfinding at the end of this, or I'll move it to another episode as pathfinding is a little bit trickier to do with lots of AIs all at the same time performantly. So, to start off, we've got our cloned AI under a folder, and this server storage AI script here, let's change this to a module. But before that, we need a way to initialize all of these AIs so that they all run the same AI. So let's do a new script called AI init. And we're going to get that folder from workspace. So NPCs folder, workspace, go to child NPCs. Now I can put this AI in here. So the actual AI class, but I'm going to move it to a separate one. So that way it's easier to differentiate between them. So in here, I'm going to add here NPC class. So this is just going to be a basic class. In Lua, there's two ways we can do classes. There is this method here. Class.new. So this is the constructor for the class, and then it's going to return a set meta table of a blank table to the class, which in this case we'll have to do it like that. So that's one way of doing it, but the problem with this way is that every time you create a new class, you create a new meta table here, and that's very memory heavy if you have a lot of NPCs. So we're actually going to change this and do class underscore index equals class. So that way it's only using one table, which is this one with the constructor in it. And that will be our meta methods where they are stored. So all the AIs share the same meta methods. However, we're only using one meta table rather than n number of AI meta tables. And then let's just separate these so it's easier to read. So I like to put self separately, and then we return set meta table self class. And then I separate that one again. And then I return self. So when you set mid table, it does return the table, the input table here, I believe. Oh wait, no. So it returns the meta table, which is this one. But however, we can give either of them, as self in this meta table refers to this table here anyways. But because we are going to have initialize function, which I'll make right now. So function class init. So that you can do init or initialize, anything like that. But that's basically the startup function of this AI. And we're going to run that right here. So as you see, there's a noticeably different way I've set up this function. This one's a constructor, so I use .new. This one's a class method, so I used colon. So the reason why I use colon is because self is automatically passed through as the first argument in the environment. If I use dot here, I would have to pass self, and this makes it a static method now. So static means it's not actually attached to this meta table. It's attached to this table up here, and we have to pass the class that we want to edit directly through the function. But by using colon, that's already done for us, and we can access self right there. So, now that we've got that, let's do some functions. So, obviously, when we had our AI, we had different things happening in it. So, let's have a look at what type of activities we had. Firstly, we had a attack function, which was called attack character. We had a seek character. And we had a patrol. Function class patrol. And then we had a update method, which is this while loop here, but we'll move that to a external loop, which manages all of these classes at once. So here we'll have update. And there we go. And then we'll need this find nearest player. We'll optimize that again later, but for now, let's add it into a utility function. So let's make a NPC utility. Actually, I could probably just name this utility. I'll keep it NPC utility. And this is going to be returning a table of functions. So let's do that. So module scripts just return whatever value is returned at the very end of the script, or whatever is in the global scope. So if I have a function like module.find nearest player, if I have a function like this, if I return something in here, this only returns it for the function when it's called. When it's out here, it returns it for the module. And that module, whatever this returns, that's what the variable is in another script. So if I require this NPC utility, what I'm going to get from that is the table module, since I'm returning that for the module. And that means I can access this find nearest player method. So if I try use that, you can see that it appears here, and we can just pass in a vector3 for the position. And while we're here, let's add the NPC class. I'm going to actually call this a base class. So let's do base class. I'm going to actually rename that to base NPC class. NPC class. Oh, that looks kind of weird. Base AI class. I guess we'll just do that for now. So I like to put headers here telling me that's the class down there, and then these are variables up here. What I might actually do also is require the NPC utility in this one. Script.parent.npc utility. Now, to remember this, you do need to remember this. You cannot make two modules require each other without a method or something that's on a different thread. What I mean by this is, since I'm requiring the NPC utility in this module, if I go to this NPC utility and I try to require the AI base class, base AI class, if I try to require that, this one's going to require this one, this one's going to require this one, and you get a recursive error. So if I try to run the game, it should say recursive error. Requested module was required recursively, because one's trying to require the other, and the other one's trying to require the same one at the same time, which just doesn't work. So to fix that, if you have a look at my framework from the RPG series, I have a init function which passes a table that has the other scripts under the same parent. So that's how I fixed it in my my framework. However, there is other ways, like using meta tables, but we won't worry about that. We don't actually need to worry about that as much. That's only when it comes down to this base AI class, and our AI systems can be really easy, so it won't matter. Alright, so now that we've got that, let's do npc base AI class equals require script.base AI class. And let's just, for the moment, do for underscore model in ipairs npc folder get children do, and I want to do npc model dot npc base class dot new. So actually I haven't even returned the class here, so we want to return the class for this module. So if I do this again, we have dot new. That's our new npc object or class object, which in this case I just call npc class. And then I'm going to have a table up here for active npc classes, or active AI classes, something like that. Something just saying, hey, this is all the active npc classes. Actually, I'll call it active npc. Active NPCs. Active NPC classes. It looks weird, but I'll just go with it. But yeah, so when we do this .new, everything in here are called parameters. But when we have a look here, everything here is called the they're also parameters, but in constructors, they are the initializing data for the class here. So what I mean by that is if I pass in a model, which is going to be the NPC model that we want to set up, and we use that, that is the constructor passing data that we pass into the constructor directly to the new class. And hence it's the constructor parameters. And I was trying to say a different word there, but I forgot what it was, but I won't worry about that. But essentially we've got the model there. Let's get the spawn position like we had in the other scripts. So model get pivot dot position. To make this easier to read, I'll do it like this. Model get pivot, and I won't worry about adding them there. This is slower, just so you know, but it's just going to be easier for you guys to read, so I'll do it this way. And then under initialize, that's actually where I would have put this. I'm just going to do it in here. Initialize is like if you need to set up any collision groups, any I don't even know what you would set up in here, but for this that is. But yeah, that's just in case you need to set up something when the class is made. Like if you need to add tags or set up the model for ragdoll, whatever. We've got our attack character, seek character, patrol, and we've got our update function, which will update the AI for us, which is the term abstraction, where you layer everything. So in here, let's add that model, and then we'll add it to the active classes, and then all we need to do is have a new run service loop. We're going to do run service.heartbeat next function. Let's do __ active class in IPAS active NPC classes do active class, and we'll just call update. So in this update, we'll have a check to see whether or not we actually want to update or not. But this is abstraction. We'll let the class handle that and not this script here. And that's pretty much it for this script. Let's jump back to this AI class. And actually, we'll jump to the utility and put this in there. We need the players. Now, also notice that we don't use tracking distance here. Oh, we don't have a tracking distance, so let's add that as a argument. And there we go. And this actually will be max distance, not tracking distance. And then we'll set it so max distance equals max distance, or let's just do math.huge. So what this little trick here does is it says max distance equals, so this variable here equals itself if it exists. If it does not exist, it will just use math.huge. And then yeah, we'll just do our code there, and then we'll turn the character and the distance. And then we can get rid of that. Now also when we have a look here, we want to add tracking distance here, so that way we remember to add that in the actual when we move it over here, so we remember to actually add it in there. But yeah, so now that we've got that, what we need to do is make it so the AI only updates once every so often, or when it's ready. So what we can do here is say a tag here, self.ready for update equals true. We can use this tag to say if self.ready for update, then self.update equals false, or update, and then that's it. Oh, and then we'll do back to true. So class.defer. So I'll explain some of this here, but essentially we check if ready for update is true. If it is true, we set it to false. So we do this so it only updates once. Then we do the update in this new thread, so that way we don't yield anything here. So we don't yield this update, which will yield the while loop in here, or this heartbeat loop. And yeah, so we'll defer that to a new thread, and defer basically means spread automatically across multiple threads. If they're automatically spread this thread, like activating the thread over multiple frames if it has to. So that's if you have like 500 NPCs, it will do like 100 per frame rather than doing all 500 at once. If you want them to immediately update, do spawn. That will immediately run the thread. But defer will spread it across multiple threads or multiple frames. And then we'll do the update stuff here. Tell the script to update again. And then yeah, we'll just tell the script when to update again. And then the next heartbeat, it will run the update again. But yeah, so that's the general idea for this, and I'm going to change this code a little bit so it's not so indented. So here I'll do if not ready for update, return ready for update equals false. So right here we're saying if it is false, so if ready for update is false, we just want to return. So that means go back out here and then go to the next iteration of the loop. And if it is true, we want to set it to false. So we only let this run once, or this update function run once at a time. And then we want to defer right here. So this is our update here. And then once our defer is finished, we want to call the update. Now I could probably actually just move this to a different function. Actually, let's do that. Check for updates. Let's do that there, and then we'll run self updates here. And then we'll do this here so it makes more sense. So here we'll check for an update. If we can update, we'll call the update function, which is this one up here. And then once that update function finishes, we'll allow another update to happen in the AI. And then pretty much from this point on, it's just copying everything. So let's copy that update in there. We've got patrol area. Let's copy that in there. We've got seek character. Let's copy that in there. So we'll fix everything, but let's just copy these into the respective functions so we can fix them. Let me just space them out. And then we've got initialize, so we'll need attack animations. So let's put that one in the initialize. We've got variables. We'll need them inside this self. So let's just put them in here for the moment. So the reason why we want these variables in this self table is so that if we want to edit these properties of these variables, we can just do self dot, let's say last patrol tick equals tick. Or if we're in an external script like this one, we can say active class dot, and then, you know, model spawn position. We can edit that variable directly. And then what we can do next is we need some of these additional variables here. So we'll need these two. Let's put that in there. Move to function. That will be a global one. And that's actually going to be in the NPC utility anyway, so we won't have to worry about that. We need terrain here. And do we need players? We don't need players, okay. And yeah, that's pretty much all of that. Let's add these parameters. So attack character, target character. We want to seek character. We need the target character. Patrol area, we don't need anything. Oh, actually, it's patrol area. And there we go. That's simple. We just copied everything from those, or from this AI script into the other one. Let's also move this attack animation to replicated storage. And let's close this AI script and delete it. We don't need that anymore. And what I think we should do first is set up these variables here. So what I like to do is separate these by their sort of like reference. So anything instance-wise, I do first. So self.humanoid equals npc wait for child humanoid, which is the model. Self.humanoid root part equals model wait for child humanoid root part. So that's those two done. And then let's get all of these in here. So now these are all a part of this class. And we should probably have a config for AI, which I might actually do. So let's go replicator storage. Let's do a new module script. Let's call this config or AI config. For now, let's just do module.simple AI. And let's just move these into here. Like so. And then in here, let's ask them to give a config table. And then we can do self.config table equals config table. And then our initialize here, this one right here, we're going to pass in that AI config.simple AI, which is that one, yeah. And then config AI is replicated storage, wait for child AI. So let's get replicated storage. Let's get the AI config. So I'll put that like AI config equals require replicated storage, wait for child AI config. I'm gonna move that to the bottom there. There we go. So this is initialize all NPC classes with the simple AI config table. Keep updating the AI. When the AI class is ready to be updated. That's important that we remember that the AI class can tell us when it's ready to be updated again. And then here, so under NPC utility, this is where I want to put that new move to that we were using. I want to put that under this NPC utility here. Now, in some cases, you may not want to do that. You may want to keep this separate as a move to module. So for the sake of this, I might just keep it as a separate module. Yeah, I'll just keep it as a separate function module. So I'll leave that there. Move to function. And we can just bring that here. So let's grab that. Local move to function. Require. Game get Sarah's replicator storage. Wait for child. Move to function. And then in this AI config, let's do attack animation equals script attack anim. Attack animation object. So I'll shorten that to anim object. So that is the attack animation for this config. So if we have different types of AI, we can have different attack animations, and we can set these different variables here. And let's just separate them. So that's like attacking distance, tracking distance, patrol distance, and then we've got attacking information like the damage and animation. So now that we've got that, let's do instead of script.attack animation, it's going to be self.config table.attack anim object. And then instead of humanoid, it will just be self.humanoid. Now for the sake of this animator here, let's add that here. So if not self.humanoid, or actually we can do this in the initialize function now. If not self.humanoid, find first child, which is a animator, then, now let's put this in a variable so we can shorten down this bit here. So local animator equals that humanoid, find first child, which is a animator. If there is no animator, we just want to create it. And put it under the humanoid. And then we can use that same animator to load the animation into the character. And then this will be self dot we should probably have an animation table, but I'll just do a direct variable reference. So let's just have that there. I'll just put it as nil for the moment. but we'll set that variable there. Or actually, I'll, yeah, add animation track, so we know it's the animation track rather than the animation object. And then here we can say, if that animation track is not nil, then we want to play that animation like before. And then, yep, that's the same. So we'll leave that. And essentially, it's just adding self everywhere for the most part. So like patrol distance and the tracking distance, we'll have to come back to that because we need to go through the config table for that. But a lot of these just you need to do self. So remember to use colon for these ones since you're accessing the class function. You need to pass in self as the first argument. So using colon for it, it will pass in self by itself. That's weird to say, but yes. Like that, and that's everything. So these ones we do want to keep separate. That's important. So we can actually add that there, that there. We want that directly under the class. That one there, that one there. And then all that's left is the config ones and the utility function. So we can just do npc utility, find nearest player, the position, and the max distance, which will be through the config table. So now let's do that. Self.config table.tracking distance, self.config table patrol distance. And yeah, let's actually make that a variable. Patrol distance. So that way I can just use patrol distance. Like that. I'll separate them. Like that. There we go. And then down here, let's also do that. Self.config table.attack distance. Patrol interval. Attack damage. Attack interval. And that's essentially it. Now, it's all... Let me just go back to that update function that we have here. Remember that we do this in a new thread. That's important because these can yield. So if we have a look at the move to function, that yields the thread until it's finished. So by putting it in a new thread, it only yields that new thread and not the main thread which checks for updates. And then anything like, actually I don't even think, yeah, it's only that move to that matters. But yeah. And I think that actually should just be it, unless we get any errors. So for now, let's just place these a little bit more spread out. Let's try run this. So we got our first error. Let's have a look. So tick minus self patrol tick. Self patrol tick is 0. Self config table patrol interval. Ah, we didn't put the right ones. So we've got attack interval and patrol interval. Let's move that to the config. And there we go. So you can see it's spamming patrol a lot because it's doing it for all of them. But if I go ahead, go inside here, and I disable that, there we go. So the reason why we're spamming it is because we don't actually yield the threads. Remember that we have this patrol interval check here. So let's say it can't find anybody, it's going to run that patrol interval. It will check this, but if that returns false, so if this condition is false, it's going to end the update immediately. So what we could probably do is just else task.wait 0.1, and that will slow it down. Otherwise, what we can do is just update all the AI slower. So what we'll do is local counter equals 0, counter plus equals dt. If counter is larger than 0.25, then counter equals 0. Actually, we'll do this other way. If counter is smaller than 0.25, return counter is equals 0. So this way, only allow updates every 0.25 seconds. And additionally, instead of doing it in a run service loop, we can actually just do a while true do path.wait 0.25. We'll just run all that, which is probably a better idea to do that. And actually, if we do that now, that should work. There we go. So now if I jump in, we should be able to make them all follow me. Oh, yeah, so you might need to disable collisions and all that. Actually, it's updating way too slow now. Let's go back to here. Let's do like 0.05. That might be a little bit quicker. Let's pull these guys in. Yeah, they're very bouncy. It's weird. Oh, there we go. So all the AI do work, and they're all tracking me. If I stand on top, can they still attack me? No, they can't. Okay. Oh, yep, they can. But yeah, so that's we've got one table that manages all the AI classes, and then they can all attack us. They will update, and yeah, that's that. I definitely will be doing pathfinding in the next one. This one's taken a little bit. But I do want to introduce one more thing, which is inheritance of this base AI class. So what we can actually do is, inside this initialize here, let's do self.humanoid.walk speed equals 10. So this is our default walk speed is 16. So this is slower than the default walk speed. And the reason I want to do that is because I want to make it so that we can inherit this base class, and we can have it called fast-based AI, or fast-based AI, which basically means that it moves a lot faster than these other ones here. So what I can do is, if I make a new module here, module script, I call this the fast AI class, and we just do a module here, but what I'll need to do first is require the base AI class, require script parent of base AI class. I need to do set meta table, an empty table, which is going to be the module. Well, actually, this should be class, not module. So we're going to set an empty tables meta table to the base AI class's meta table. This is just how inheritance works in Lua. So we'll set it to this class meta table. Then we'll have the index point to this class, not the other class. So we want to have a new class. And we do want to copy these methods into here. Like so. Like that. And what I want to do in this one is say local self is set meta table base AI class dot new, and then I'm going to pass in the argument to that one there, and then any yeah, it'll have to be like that to class. Yeah, so this will be local super equals that one. Set meta table super, and we want to return that one. So then we can do super dot whatever properties we want to add. But also I do want to do one more thing, which is I want to do class dot super equals base AI class. So this will actually be self now. Actually, I don't even think we initialize anything there. Yeah, so it's mainly here where I want to do it. So I want to do self.super initialize. I think that should work. Otherwise, it's going to be class initialize self. Or class.super initialize self. Yeah, so I got to pass in this self table there, and then I can do self.humanoid.walk speed. No, I forgot. We do that automatically in here. So if we scroll back up, we do initialize automatically, so I actually don't need to do that. But I'm going to set the walk speed to 32 here. And then I just call these methods like so. I believe that's how I should be doing the super. I can't remember. But now if I do this AI script out here, let's just call this one fast AI or fast NPC. Let's put that one over here. If I do table.insert active NPC classes, and I want to get NPC fast AI class, require script.fast AI class, .new, I want to give it the model simple AI, so this will be workspace.fast AI, or fast NPC, and I want to give it the simple AI. If we try that, I believe that should work. Okay. Let's see. I don't actually call initialize, that's why. So let's do that there. And then I want to call self initialize. That's what I was missing. And there we go. So now we've inherited everything from the base AI class, but now we've also included our own methods where we call the super, which will be all of these ones here. But we also have our own initialize function, which will change our walk speed to what we want. So this is basically do additional stuff before calling base AI class methods. Do additional stuff after calling base AI class method. So that's pretty much the same for all of them, like that. And that way you can create different types of AI that all share a base class. So like if you need the patrol in all of your AIs, you can just keep the patrol area the same. And then you can call that from the fast AI, like we do here. And then if you need a different seek character and a different attack. Oh, I forgot the attack one. Let me grab that. Or a different attack method, then you can do that here. You can just comment that out, and then you can implement your own attack method there. Which I should probably be doing for the RPG series, where I have different AI, have different classes, and they can do their own things. But essentially, yeah, that's AI NPC AI classes, how you can inherit them to do different things, and essentially you can have your own configs for the different AIs that you want to program. You can have the configs be different tables, so your specific classes will take in a particular type of AI table, and you can have like a config class name, something like that, and you can just check that and then error out if it doesn't match or whatever. But yeah, that's essentially an advanced version of the AI. We've got inheritance, we've got, well, actually be object-oriented programming, and we've got the config module, we've got a utility module, and we've got our move to function, which can be used in different scripts also. And yeah, hopefully you've learned something very useful, and yeah, I'll see you in the next video where we implement pathfinding.